In example 10 from note 6.2, we're going to begin to solve right triangles. So when we solve a right triangle, that means to find all the missing sides and angles. So we're given partial information, and our goal is to find the rest of the information. In addition to right triangle trig, we can use some things that we already know from geometry. And the first one is the triangle sum theorem, and that says that the sum of the measures of the angles in a triangle, so this is the interior angles, adds up to 180 degrees, and you learned that in geometry. And the second one is the Pythagorean theorem that says in a right triangle with legs A and B and hypotenuse C, the sum of the squares of the lengths of the legs of the triangle, so a squared plus b squared, is equal to the square of the length of the hypotenuse, which is c squared. So in example 10, we're given one acute angle, the measure of one of the acute angles, and the length of one side, and we need to find the missing information. And that is a process of solving the right triangle. So if we look at this right triangle, we can begin by finding the missing angle, the missing acute angle. So we know that the sum of the measures of the angles in a triangle is 180, or we could also say that the sum of the two acute angles is 90. So either you can say 180 degrees minus 90 degrees minus 34 degrees is going to be our missing angle, which turns out to be 56 degrees. Or as a shortcut, you can just say that 90 degrees minus 34 degrees is 56 degrees, because the two acute angles are complementary. So that missing angle is 56 degrees. So I'll put that in our triangle. And now we'll try to find the missing side lengths. So since we're given the 34-degree angle, I'm going to focus on that angle. And now I'm going to label the lengths of the sides of the triangles according to adjacent, opposite, and hypotenuse. So the side opposite the right angle, which is labeled X here, that is our hypotenuse. So I'm going to label that. The side opposite the 34-degree angle is the opposite angle. So I will label that. So Y is the opposite angle. And the length 7 is on the adjacent side. So if we look at our triangle, we can see that we know the length of the adjacent side, and we also know the length of the, we only know the length of the adjacent side, but we want to know the hypotenuse or the opposite side. So if I think of, let's focus on X first. So that means we know the adjacent and we want to find the hypotenuse. So the ratio that we're going to use, so we have to determine which of the ratios to use. If we know the adjacent and we want to know the hypotenuse, then we're going to use cosine. So we can say cosine of 34 degrees is the length of the adjacent side, which is 7, over the length of the hypotenuse, which is x. And in order to solve this, we can multiply both sides of the equation by x. So we'd have x cosine 34 degrees is equal to 7. And then to isolate x, we divide by cosine 34 degrees. So x is equal to 7 over cosine 34 degrees. If you enter that into your calculator, you will find that x is 8.4 units. I just rounded to one decimal place. Now, in order to find y, let's use another trig ratio. We could use Pythagorean theorem, but it's probably better not to use the rounded values. So we would like to find now the length of the opposite side. So we want the opposite side, and we know I would use the side that we were given, which is exact, the adjacent side. So the trig ratio that relates the length of the opposite side to that of the adjacent is tangent. So we're going to use the tangent. So tangent of 34 degrees is the length of the opposite side, which is y, over the length of the adjacent side, which is 7. To isolate y, multiply both sides of the equation by 7. So 7 tangent 34 degrees is equal to y. If you enter that into your calculator, you'll find that y is equal to 4.7 units. So we have solved this triangle, finding the two missing side lengths as well as the missing acute angle.